Okay, let's see here. Let's look at one of our last things, which is antibody characteristics. So we're now starting to talk about different blood group systems. Okay, now remember, you've got more than the ABO and the RH system. So it's really important to be aware of that. But this chart is essentially everything that you need for understanding the blood group systems. And let me see if I can overlay on this. I don't know if I can. I can do it this way. All right. So antibody characteristics down this column, right? Okay. We're going to look at your optimal reaction phases. Your antibody class, does it cross placenta? Can it cause hemolytic disease at the newborn? Can it cause a transfusion reaction? Complement. Does it show dosage? Antigen frequency in the population? But I'm going to come in here and bracket out the groups. Okay, so this is the RH group. Let's find some pretty color. Fill color. We're going to fill color with orange. Don't ask me why. Okay, kale is another system. All right. Kale is very immunogenic in that if you're kale negative, which the majority of the population is, when you come in contact with a kale antigen, you're going to make the antibody. All right, Duffy A and Duffy B, and I'll write this down here too. All right, there you go. We call this Duffy. It's the Duffy system. We've got the kid system. And like I said, these are all different blood group systems. Kid. You've got P. P reacts at colder temperatures, which we'll talk about that too. P reacts at colder temperatures. We'll just make it pretty like that, I guess. Hell, I don't know. Okay. M, N, and S all are on the same locus, okay? That's where these blood group systems come into play. They're all on the same locus, so they share a common point on your genetic code. Lewis is not a true antigen. It's more of a substance that can be absorbed or not absorbed onto the surface of your red cells. And that was discussed a little bit during the secretor information. And then you've got Lutherans. Okay. And the Lutherans are really clinically insignificant for the most part. They're not that big of a deal. Okay, so this is Lewis. This is the MNS system. This is Lutheran. Kale. And obviously RH back here. We know that. All right. These are the main blood group systems that we're going to be talking about for the remainder of the course. These are clinically significant. Ficant. Meaning that if you come in contact with this antigen and you lack it on your red blood cells, you more than likely will make an antibody. They are listed in the order of their immunogenicity. So, immunogenicity, right? Their power to elicit an immune response. So, over here, we've got a stronger, all the way over here to a weaker. So, kale is right here. It has the power to elicit a strong immune response, more so than Duffy or Kid or MNS, all right? But that doesn't mean that the others won't do it. So here we go. Optimal reaction phase for your for these typically is going to be 37 or 37 degrees or around that area, unless it's something special. So I'm just going to do the something specials. P is immediate spin. It's cold. It likes colder things. Now remember, immediate spin does not mean that it's that cold has to be 4 degrees. Anything less than body temperature is considered cold, and it's immediate spin. Optimal reaction phase for M is immediate spin as well. Those are the two that really stick out as being the ones that you're going to get at immediate spin. Obviously, your D antigen is as well, because we do that in our ABO. Most of these antibodies are IgG in class. M can be either, we'll say both, but typically M is usually IgM. P is usually IgM, colder acting. Everything else pretty much is going to be IgG or bounce back and forth. Now, remember, can it cross the placenta? I'm just going to go like this, and we're going to merge this. Yes. And yes to that. Yes to that. They all can cross the placenta if they're IgG, okay? Every last one of them can, so let's just write that down here. If the antibody is IgG, it can cross the placenta. And if it crosses the placenta, guess what? It causes hemolytic disease of the newborn. So if it crosses the placenta, it can cause hemolytic disease of the newborn. Definitely two things to keep in mind. Can it cause a delayed transfusion reaction? One of the main ones that causes this are the kids. And we consider the kids to be transient. Kid antigens, actually kid antibodies, are transient. They can come and go. All right, so that's very important when we're talking about ruling in and ruling out different things. Activation of complement. Remember, to activate complement, it takes 2 IgG or 1 IgM to activate complement. So in strong reactions, yes, these antibodies can actually activate complement, which would ultimately destroy the red cell and cause hemolysis. Dosage. We can see dosage in the Rh system. Okay. Let's see here. Merge. We'll say yes. And we see it significantly with M. Definitely with M. You can see it with other things too, but for the most part, definitely with M. So let's see here. Yep. Okay. So what I need you to do is, with this chart, I need you to keep it with you, because as we move through the rest of the semester, we are going to talk about these different blood group systems individually, and you'll be adding different things to this chart. It's going to really be helpful to you, okay? But for right now, we're going to talk about the RH 37 or room temperature. Typically, for the most part, it's always, let me see if I can get the paste going down here. Typically, for the most part, it's always going to be, let's see, come over here. You're not supposed to do that. Copy. Paste. I give up. Okay, so E, little c, and little e are the same as 37 in room temperature. All of these can cross the placenta, okay, if they are in IG, yep, okay. We're going to say, for the most part, they're IgG. Do they cause hemolytic disease of the newborn? Absolutely, they can. Can they cause a delayed transfusion reaction? Absolutely, they can. Can they activate complement? Yes. Different ones at different degrees. So I am going to leave blank your antigen frequency in the population, but remember that RH was 85%. Okay. Little e is 98%. Go and get your percentages for the other ones from your book, and we'll talk about that. So we're gonna stop this piece right here, and we will come back as we move into Kale later on and talk about completing this chart. But this is really important for you to have because it'll help you understand which antibody's doing what and how they're reacting in the situation.